Okay, so your design is going to look something similar to this, in which you're going to draw the roller coaster, design it the way you want it, and then you will need to put fairly accurate measurements. They put speed here. You're also going to need to put speed and the height at which the parts of the track are. And you're going to need to use the equation for potential energy and kinetic energy. And you're going to need to calculate at a few spots. So I'll give you a few examples. So here's the equations, just like in that worksheet. So mass times gravitational force times height for potential energy. So this would be for spots like at the top up here when the object is not in motion. So if the object is not in motion, if it's at the very top of a peak, or if it's just starting right here and not moving yet, this would be a spot where you can calculate the potential energy. So for example, if they're starting here, now you can do yours in feet, they have theirs in meters. You can calculate it for potential energy here right when it started if it's not even moving yet. So you can do the mass. So you can research the mass of roller coasters, Google it, and get a fairly accurate measurement. Let's say the mass, what you need here, let's say it's 5,000 pounds. You would put that mass. Then you'd put the gravitational force, just like in the worksheet, that's going to be 10. So it'd be 5,000 times 10. And then if this was your height here, right at the start of the roller coaster, you would multiply that by 22.5. And then that would be one of your calculations. Just use the calculator, calculate it out, this times that, and that would give you the answer for potential energy. Then from there, similarly with kinetic energy. So for kinetic energy, that's going to be when the roller coaster is in motion. So at a particular spot. They have a speed here, and you'll also do some research to kind of get some average speeds of roller coasters at certain spots. So let's say the spot you're picking is right here. If it was traveling this speed, we can use the formula for kinetic energy. Remember, the formula for kinetic energy is zero point 0.5 times the mass times the velocity squared. So you would just plug the numbers in for your design of your roller coaster and multiply it out. So you again would put the zero point 0.5. Then you'd have the same mass of the roller coaster, right? The mass is not changing throughout your roller coaster ride. The mass is always going to remain the same no matter its location. So you would put the 5,000 here. And then you would put the velocity squared. So let's say yours was just like this one, 8.26 meters per second. You'd put 8.6 and then squared. So for that one, you would do 8.6 times 8.6. You'd get that answer and then multiply by 5,000 and multiply by zero point 0.5. That would get your final answer. So you'll design your roller coaster. It can look something like this. You can try to do more of a 3D style where it would have like curves like this one here on the top page. And you show some curves. If not, you can kind of just design it like this on your paper. But remember, just like it says on the assignment instructions, you need to put the height at 10 different spots, and you need to put the velocity or the speed at 10 different spots. So like how fast would it be going right here? Is it going 30 miles per hour? And track those at 10 different spots. And then you need to do 5 measurements of each. You need to do 5 for kinetic energy and 5 for potential energy. So pick 5 of your spots to do for potential energy and 5 for kinetic energy and add that to your poster.